and then for this you're going to have the weight and the unit, which is newtons in this case. You have to have a title, so in this case weight versus mass. You could give another title. Irrespective, you have to have always your name, and you're going to understand why you have to have the name. So I'm thinking of a fictitious student here by the name of Bobsled. So in this case then, Bobsled took the data and took the 5 different data sets and labeled each one of them A and B and C and D and E on their table. And at the same time, they show which one of those. So in this case, whatever the measurement of this is, obviously here the mass value is whatever this is, and the weight value is whatever this is. Now, when you are drawing your scale, it is important. It doesn't matter that this matches this, but what matters instead though is that if you select to skip every 4 squares, you must continue skipping every 4 squares. So for example, I'm just going to throw in some numbers. Your numbers are different than mine, by the way, okay? But I'm just going to give you some examples. So let's say this one is representing 0.1. If this is representing 0.1, that means for every 4 squares, you are going to go 0.1. You're not going to go anything else. Therefore, the next point, added 0.1, that would be 0.2. Added 0.1, that's 0.3, etc. Okay? And then, as far as the vertical here, let's just say, for the sake of it, you skip 2 instead of 4 squares. And let's say the first one is representing, for example, 0.5. If this is representing 0.5, whether you like it or not, you're going to have to continue with 0.5s all along. So this would be a 1, this would be a 2, 1.5, 2, etc. But in this case, I'm going to just go with whole numbers. Of course, in your case, what dictates the breakdown of the scale is the data values. It is important that you don't choose a scale that would squish the points together. Choose a scale that would spread it almost across the whole, wide sheet of paper that you are using. So in this case, you have 1, 2, 3, 4, etc. Okay? Now that you have a scale, you have the units, the labels, the title, the legend to indicate which points are which. At this point, my friends, you are ready to do what we call in physics modeling. And also in math, people would refer to it as modeling. What does that mean? Yeah, so you look to see if there is a pattern to the data. If there is a pattern, you would like to identify, is it a linear pattern, or is it a quadratic pattern, or is it some other kinds of patterns? In this case, you guys are going to get a linear relationship. I know that for a fact because we've done this lab 50,000 times before. So how do you decide where the line should go? The biggest misconception that people have about the line of best fit, or it is called also the least square line, is that they think it has to pass through all the points, or it has to pass at least through one of the points. No, that's not the requirement. The requirement is, when you eyeball it, is to choose a line in such a way that the distribution of the points, around the line is as balanced as possible. Okay? Specifically, what I would recommend is you pay attention to these vertical distances here based on where you put your line. So for example, if I set my line right here to pass only through this point C, for example, then I'm going to have this here. Well, this is below the line. It needs to be balanced above the line. Well, you could balance it with this point. Are you following me so far? And this one is right here. It's below the line. So this kind of balances it. So this point, this line that I have right now seems to be a reasonable one. Therefore, I am going to put that line, and notice here, I'm going to draw that. And please, when you draw it, you do not stop. You should continue all the way until you cross, here we go, until you cross your y-axis. So it ends up being like this. And at the other end, you should continue all the way, and this is indicating that you continue it all along. Notice here, I did not force the issue that it would go over the 0, 0 point. Why? Because then my data is not dictating that. And you don't force the issue either because you don't know yet. So you let the data decide as to whether the line could conceivably go through the 0, 0 or not. Cool or no cool so far? Okay. Now, I have a line. So how could I establish a model? To establish a model is to come up with an equation that would, represent that line. Well, what's the general, form of an equation of a line, my friends? Y equals what? Say it loud, please. Y equals mx plus b, correct? That's perfect for math. So, y equals mx plus b is perfect for math. For science, that's ugly. No. Ugly, which is worse than ugly. In science, you have to have the context. You can't just have anything you want. So, what did we graph along the y? Please. What did we graph along the y? The weight. Therefore, this should be w. Okay? What did we graph along the x? The mass. Therefore, m. Now, this becomes a problem. Okay? I've never understood why mathematicians would use m for slope. Forget it. I'm going to use s. Slope starts with s. Therefore, I'm going to put s. Is that okay with you? Okay. So equals some slope times mass plus the intercept. Nobody cares about it. It doesn't matter. It could be b still. Cool or no cool? So don't ever report in science the typical equations that you would learn in math. Instead, change them so that they would have the context of what you're dealing with. Are there any questions? Cool. Next, my friends, is the idea of determining, so the idea of establishing the model becomes the idea of determining the constants. That's it. Because the weight and the mass are the variables. Those are the ones that you measured and changed, so you would be able to get something. Okay, so how do we go about determining the slope and the intercept? I'm going to go with the intercept first because it's easy. What is the intercept supposed to be, the y-intercept? The y value where the line does what? Crosses the y-axis, correct? Therefore, it's this value right here, my friends. Well, what's the value of this? So b equals, this is in our vertical axis, so it is representing a weight of some sort. Okay? So, what's the value here based on my scale? Say it louder, please. 0.5. So it would be 0.5 newtons. And the unit is dictated by that. So guess what? Now I'm going to improve my model. So now it's W equals, I'm going to hold on that one, the mass, which is my variable, okay? And then plus, and look what I'm going to write now, 0.5 Newton. Does this mean you guys are all going to get 0.5 Newton? No, because you have a different set of data. Cool or no cool? Okay, so now I need to worry about my slope. So how do I go about determining the slope? So I'm going to use a different color so we would be able to differentiate between the two things. Okay, so in this case, how did you learn in math to determine slopes? You do what over what?
Rise over run.
Very good. You do rise over run, correct? Learn from Nadj. Stop using that terminology. Bad idea. Here's why. Because, this is, by the way, outside of this, so you would not be able to see it. So, the idea is this. If I give you a graph like this, this is not a rise, this is a drop. Are you following me? There's no such thing as a rise in this case. It's a drop over the run, if you want to call it that way. Well, that's kind of silly. Better, you should refer to it as vertical change divided by horizontal change. This is why when you guys learned it in math, you learned as the slope will be delta y over delta x, correct? Well, that's a change along the vertical divided by the change along the horizontal. So better refer to the slope as a rate of change. Cool or no cool? So in this case, I am going to take this s here and I'm going to determine its value separately right there. So I'm going to say s equals change in No, we don't have a y in science, remember. Changing the w, the weight. Oh yeah. Divided by what? Changing the mass, you bet. So, I need to get some number for the change in weight over some number in the change of mass, and I am going to determine that somehow. Well, how do I determine it? Listen carefully, please. You select the biggest possible right triangle. So, you go like this. And by the way, you select any arbitrary stuff. Now, usually I don't pick my points. Avoid your points on purpose. And then I pick points that are easy to look at. And I use, instead of a dot like this, I'm going to use an open circle so you would know that it is not part of my data. This is just a point I'm selecting to be able to do my change in the vertical over my change in the horizontal. Cool or no cool so far? Okay, so now I'm going to go as far away as possible to determine something else. Guess what? This one looks like it's convenient to me. It's right at the intersection between two lines. Cool so far? So now I am going to draw my right triangle that represents the changes in the x and the changes in the y. So in this case, I'm going to do that. And I'm going to have that. So now this is representing my delta W. This is representing my delta M. Listen, this is not counting the squares. No, you have to use whatever the values that your scale is representing. So in this case here, you see how this is, 2 squares and 2 squares and then, one additional square. What did we say every 2 of these is supposed to represent? Say it louder, please. 1 what? Newton. 1 Newton. So this is 1 Newton, 2 newtons, and half. Therefore, my delta W is equal to 2.5 newtons. Cool or no cool? Now, I'm going to go with the horizontal. So again, we're supposed to go 4 squares is a 0.1, correct? So, 4 squares right there, that's 0.1. And this one is 3/4 of that. So overall, what would it be for me here? So it would be 1 point what? What do you think? 1.75? Would you agree? Okay. So in this case then, 1.75. And what's the unit? Kilograms. Very good. So now I'm going to write 2.5 newtons divided by 1.75 kilograms, and I am going to actually do the division. Would someone please be kind? Divide 2.5 by 1.75. And how many sig figs should I stick with? 2. 2, because in this case you count the least number of sig figs in the process. So, give me the result with just 2 sig figs, please. 1.4. So in this case, instead of putting this, do I have someone second in the value of you said 1.4? Anyone second in that? Whoa, 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 whoa. Say bad Nadj. Carrie, it is not 1.75. Exactly. What is it supposed to be instead? 0.175. Yes. Oh, I love this. Here we go. 0.175. So instead of this, I'm going to put 0.175. Would you agree now, Carrie? That's it. You're a legend now. You went into the video. Here we go. Now, do me a favor, please. So if I divide this now, that would not be 1.4. Instead, what should it be? Come on.
14.3.
Say that again.
14.3.
But we're going only with 2 sig figs, therefore.
14.
Just 14. Very good. So 14, what's the unit? What's the unit? Come on. Newton per kilogram, isn't it? And guess what now? You put this number over there and you end up with 14 Newton per kilogram. Notice here, this is now, my friends, this is my model of this thing.